Hello everyone, good afternoon. Welcome to this problem solving session of Advanced Geomatics Engineering NPTEL course. Today we are going to discuss about the further things on digital image processing. In previous class, we learned about the various type of like what are the basic substitute of image and then whereas various way to increase the contrast of an image. Either it's by stretching a histogram or histogram equalizations or many different techniques we have learned. And then we have also learn about the different kinds of filtering, high pass and low pass filters, and some applications of it and some numerical concepts. In today's class, we are going to discuss more about the different types of indices which we use to differentiate between different classes, as well as we are going to hello, yeah, hello, am I audible?
Good evening, sir. Yes, sir, you are audible.
Yeah. So today we are going to learn about the like continuation of the previous class. So today we are going to learn about the some thing which will be used in the differentiating the different objects in remote sensing images. So basically, if a given a remote sensing image or any image, how will you differentiate between different classes automatically? Or if you want to make an algorithm of it. So how will you differentiate between water and vegetation, water and urban classes? So this lectures is going to be focused on different spectral signatures, derived indices, and then how we can do that thing using the image classification, where we are going to learn about the unsupervised and supervised classifications, some applications of it, and how to do the accuracy assessment after doing this image classification. So with this, let's start today's session. Let me share my screen. Is my screen visible?
Yes, sir.
Okay, fine. So basically, any doubt in the previous class?
No, sir.
Okay, so I think you all of you have gone through the video recordings of this week, and if not, then please do it and submit your assignments also. Now let's start with the basic about the differentiation methods. So we'll start with the questions. The normalized difference vegetation index, which is known as a NDVI, is bounded between. So, do you know about this index?
So -1 to +1.
Yes, yes, that's right. So the correct option is B. So, do you know what is NDVI? Like, why do we use it?
Yes, sir. To enhance the vegetated areas and to enhance some important features or specifically related to the vegetation, where is healthy vegetation is existing,
Yes,
where vegetation is not healthy, where greenness is more and less.
hmm. So basically, when we see,
Specifically, it can also highlight the vegetation species in the shadowed areas, just like in hilly or mountainy areas.
yes, yes, exactly. So basically, the main use of NDVI is to differentiate vegetation from different classes, mostly from water. And here, the one thing which we are utilizing is the near infrared band, as vegetation has higher reflectance in near infrared band compared to the green band. So better idea to use near infrared band rather than using it as a green band. Why? If you just use green band, if you will think that vegetation is green and then it will give you the signature. But the problem is the reflectance in green band is very less. Apart from that, there are multiple features which are also green in color, such as if you see artificial grass, or if you take an example of algae water. So all of them looks green, but they are not vegetation. So because to differentiate those things, we have to use this NDVI index, where it will give mostly effect of the vegetation only. Now here also, once we get the vegetation, how do we get to know that whether the vegetation is healthy or not, or what is the density of vegetation? So it will also helpful into that as well. So have you done any calculation of NDVI using any imageries?
Yes, sir. I have calculated NDVI actually in second semester.
Yes.
We used to calculate these kind of indices like NDVI, NDMI, NDWI, and in our this third semester, which is ongoing, we
Uh,
are mapping like flood hazard zonation and landslide zonation. So we are using these indices like NDVI, NDMI,
okay.
and
Fine.
we used to calculate these indices using Landsat 8, Landsat 2 satellite imagery.
Okay.
Sorry, like Sentinel 2 satellite imagery.
Hmm. Great. Great.
Yes.
So now let's move forward. In NDVI, extreme negative values typically represents.
Sorry, sir, can you repeat the question?
In NDVI, extreme negative values typically represents which feature? Soil types,
Urban features, sir.
soil type, water feature, rock feature, or urban feature.
Sir, urban features.
So here in question it is written extreme negative. So extreme negative means if you take the example of NDVI formula, it is near infrared minus red divided by near infrared plus red. Okay, so
Yes,
let's
sir.
let's visualize your answer. Your answer is not correct. It should be water. Okay, because water has lower reflectance in the red band, and that's why the mostly negative values will come because of the water. So let's take an example of. So have you used Google Earth Engine before?
Yes, sir, but with many errors.
Okay. So we'll take example of directly GIMP sensors only, or we can take Modi's data also. So basically, if you don't know anything, like we can just don't write the code, but directly see the results of NDVI, the products which are already given by the Modi's satellite. Mm. So basically, this is an NDVI image. And if we see, let's say some area, particularly in, let's say, urban areas. So this is the Ahmedabad city. And now let's inspect the value of NDVI over here. So we are getting 1766. So it's like multiplication factor here is 0.0001. So it's around 0.18. And it says it is 1 kilometer data. It will not give proper. So if you see wherever vegetation is there, it's high. But if you see wherever the water is, so let's say if we see some big water bodies, let's say here this reservoir. So if you go there, you can see the values as a negative. Okay. So basically, if water is there, then it will show the negative values. But if urban features are there or barren land is there, then it will show the values near to zero. We can take an example of here Gulf also. So see, you can see the values in the negative range. And now we can try with some high resolution data. So it is coming here. So if you are using Google Earth Engine, then this error is persistent, as like in the recent images, they have removed this QA16 bands from the Sentinel datasets, and that's why the cloud correction will not happen using this QA16 band. Rather than it will use some other way. So basically, if you are using Google Earth Engine, let's rewrite the code. How you can proceed with the. So basically, whenever you are writing any Google Earth Engine code, so first you have to select an area. So let's select an area. Let's say I want to generate a NDVI for a portion where let's say we have water body or everything available. So I will take an example of Gandhinagar as it has all those things, all features. So first step is to select the area. If you are doing any remote sensing analysis. So here, let's make it big. Yeah, there we go. After that, you have to import the data sets. So I will just copy paste my codes. Another thing is, so afterward, you have to import the data sets. So here for to importing data, you have to write variable data sets and specify the collection of the data sets. And then after you can give the other criteria that select for the like give the images for the given geometry, and you can reduce the cloud cover also, and then algorithm to remove the effect of cloud. So this map.mask s2 clouds will remove the effect of clouds, and this is the algorithm which is like directly comes with the any sentinel image. So using that you can use this and import the imagery. Now once we run this much code, you can set the zoom levels also. Select the zoom level. So right now we are getting 10 images for this area. Okay, now we want to visualize this image. So we have to use another layer, which is map.add layer. So that line will represents the image. So map.add layer, then the variable which you want to see. So we want to see mean NDVI, or let's say mean just image we want to see. All like we got 10 image, but we want to see a mean of all 10 10 days or 10 images. So that's it. We will take data set dot mean or median or maximum minimum, whatever you can take, but generally we prefer median to avoid the too bright or too dark conditions. And then we will clip it for the given geometry, and then after we want to show that layer. Now to show that layer, we have to specify the colors. So for colors, I'm using minimum value as a zero point 0, maximum as a zero point 0.5. So these are the reflectance value from 0 to 1, and these are the bands. So here 843 are false color composite. If you see the example of Sentinel, these are the specification for false color composite. And then after, we will run this code again, and what I will get is the imagery. This is a post monsoon imagery. So what you can see here, you can see the water, and then this gray color portion is urban features, and then red is vegetation covers. And vegetation also, there is a, if you see over here, then it is a continuous in nature. It means it might be a forest or something. Whereas if you see here, it is a proper shape, so it might be agricultural field. Then you see the river stretch where the water is not there, barren land is there. So all the classes are given over here. So now let's calculate the NDVI and we'll check it for different layers. So first we have to calculate NDVI for this image. So you can write the function add NDVI and then give an image. Now NDVI is a normalized difference index. So we'll write image.normalized difference. The sentinel for sentinel, band 8 is their infrared band and band 4 is a red band. So you will calculate the normalized difference and then we will rename it as NDVI. And then I will add the NDVI band in my image. After that, I will apply that to my entire imagery. So this data set, and then I will apply this function to my entire collection. And then after whatever I got, I will take a median of it and make a composite of it as we did earlier. And then we'll flip it. And then after, we will represent it using the different colors of greens. So after doing this, now this is the image which we got for NDVI. So what I did is I kept green for greater values and blue for negative values. And now let's go and inspect the values of different colors. So if this is the area where vegetation cover is like mostly it's a uh, forest and all. So you can see the NDVI after post monsoon is 0.78. And this, if you see now in this side over the farms, so wherever the crop is there, then you can see the NDVI of 0.61. Depending on how much growth of that crop is, you can see the NDVI values 0.67. And if you see the patches with light yellow color or light green color, you can see NDVI is in range of 0.17 or zero point 0.1. It means that there is a no crop here, or either the crop is very mature stage, it's not reached yet the mature stage. So it's either just sown. Now if you see the water, then water, the NDVI is, you can see it's negative -1. So it's a full water area. And that's why you can see the like index as a -1. But if you see some areas over urban patches, so here if we expect the NDVI value is 0.22, sometime if we see this buildings are there, okay, so if we inspect the NDVI over there, you can see it's a near to 0. So basically the negative one is for water, whereas if you have barren land, or say here let's say river is there and barren land is there, so if we see the NDVI over here, it is also near to 0. So barren land, then your urban pixels will represent the value of NDVI around 0, near to 0, whereas vegetation will show more than 0. Is that clear?
Yes, sir. Sir, I have a question.
Yes.
So, like we can see like any vegetation has three stages usually.
Hmm.
Very young stage, and middle stage, and
Mm.
when it is very healthy and green, and it's older stage when it is getting ripen like in yellow shades.
Yes.
So at what stage or age it will uh, have more NDVI value?
So it will have more NDY value during the mature stage. So this what you are referring that is known as a phenology. You have to see like how temporally that crop is changing. So basically, if you plot that value around that time, then you can see the something like this. I don't know it's properly visible or not.
So means during the middle age of any
Yes, yes. When
vegetation,
it
it
is
will have
fully
highest
grown or
vegetation.
yes, yes. During that time, it will give the maximum peak of NDVI. So in our
Okay.
case, like after just monsoon season, you will receive like you will get maximum NDVI like in the month of October, November, December.
So, but how we can decide by NDVI like it is healthy vegetation? Because for ripen vegetation, it is also showing lower values, or barren for barren land, it is also showing very low values.
Yes, yes. So for in that case, how we can do is first we have to see when we see vegetation, then what we are referring. Is it crop or is it some forest or something? See, if it is a forest and if NDVI is going down, it means that that forest is either becoming deforestation is happening or that particular patch is having some issues. Okay, now when we talk about crop, during that time, what we will see that compared to the other crops nearby, if the NDVI is lesser, then it might have some issues. Either the issue with soil, either issue with the fertilizer, or either any insect or some disease is there. So when we talk about NDVI, we see the spatial like connections also, not just that if NDVI value is greater than this or less than this, then it's a healthy. In general, if we follow, then if NDVI value is zero point 0.6, then crop is very healthy because, and that will also be see like not for just one day. We see the readings at 2 or 3 imagery, which will get if you are using Sentinel, you will get it every 7 days. So during that time, if it is going down, then we'll get to know there is something happening with my vegetation or with my crop. So it's just not a individual value which will give you the answer. You have to see temporally that how this NDVI is changing across the time at the same location. And based on that, you will get to know that whether a vegetation is going in which stage. First of all, what you are referring that how we'll get to know that if it is in ripen stage also, the leaves will be yellow. So in that case, how we'll get to know that is the ripen state or not, or the final mature stage? Because we have to, if we got the that here the NDVI is less, we will compare it with the previous day image or the image which we just got before it, and then we'll compare it what is a drop in the NDVI, and based on that we'll determine whether it's a, if that like NDVI time series is gradual, then it means that it is going from the crop cycle. So and if it is sudden, then we will say that there is something happening with the crop. So what we do is we take the phenology or this kind of climatology, we can say it's a mean NDVI over the time series, and then we'll compare it with the given crop that is there any sudden drop or not. So based on that we will decide that whether the crop is going in the like which condition. So it's not just about one image. You have once you find out that in one image the NDVI is less, then you will compare it with the previous day image and you will see temporally what is happening with that crop. uh, am I making sense?
Yes.
Yeah. So basically extreme negative values represents the water feature. Here the word extreme negative value is there. So anyway, like if it is NDVI is near to -1, it means it will represent water only, not the other variables. The next one is which property makes NDVI superior to simple ratio. So simple ratio is like we are just taking A divided by B kind of stuff. Near infrared by red or green by red, or similar to anything like A divided by B kind of thing. Yeah. Hi, Suraj. Welcome to this session. So we are discussing some questions on NDVI and basically on digital image processing, extracting the different signatures from the image. Yeah. So this question is, which property of NDVI make it superior with reference to the simple ratio? Simple ratio means A divided by B. Whereas in NDVI, we take normalized difference, which is A minus B divided by A plus B. So which of the following is true?
So why absolute biomass values are actually
How will you get like how much plant is there using just NDVI directly? That also. Because see, NDVI will just give us that what is the greenness of the image or pixel, but we will not get an idea that how much crop is there or what is the leaf area index or similar to that. So we need some kind of formulas or some kind of relationship to establish this biomass or other
yes, so
things.
here it is written directly, we can calculate directly.
Okay. So here the answer is normalized difference, which is reducing the scale issue. Scale issue is means like if some crop is too healthy or if it is too big and very green, then it will sometimes if we see the reflectance, then NIR reflectance will be too much. If we see the grass, then NIR reflectance will be very less. But there is no like how, if you want to define this too, then there is no clear cut marking. So to make it everything in scale of particular value -1 to 1, we are using this NDVI. So once you use this normalized difference index, normalizing if you do, then it will restrict within some range, which is -1 to 1. And that's why, because of this normalization, it gives the superior range compared to the normal ratio, where in normal ratio, values can range anywhere in between 0 to 1000 or infinite, it can go also sometimes. Because if let's say red index is 0, let's say for water, if we see near infrared value is nothing, and then if in like red, if they have some other signature, and if we apply the formula that near infrared minus divided by red and something, then the denominator will become 0 and then it will go to infinity also. Whereas in case of vegetation, we'll get more values, but still like water will have very high values. So in that case, it will become difficult to differentiate between two objects because all are having either positive side only, no negative side, or opposite signatures are not there. Okay, so with that, like we'll go to the next question. So in Landsat 8 scene, digital image DN number values for pixel in band 4 and band 5 and band 10 are 80, 100 and 30 respectively. What would be the NDVI value for the same pixel? So here you have to first identify that which band is which one. So in general, we have to use near infrared and red band only. So which of the following band is
So
near
band 4
infrared?
is red and band 5 is yellow.
Exactly, true. So if you don't know, then I think for satellites, like if even for GATE exams or for this exams also, you should remember this some of the common satellites and what are their bands, in which band they are giving the data. So if we take the example of Landsat 8 or any like any Landsat series, so they are having in their website only there are multiple indices are given. So if let's say if we go to NDVI and we just check it out that near infrared minus red, near infrared plus R. So in Landsat, if you are considering the data from Landsat 4 to 7, then the value is you have to use band 4 and band 3, where band 4 represents near infrared and 3 represents red band. If you are using Landsat 8 or 9, then the combination is band 5 and band 4. So 5 is a near infrared band and the 4 one is a red band. So like this, if you know, then you can calculate the NDVI. So here the band 4 and 5 are the corresponding red and near infrared band. So depending on that, if we apply the formula, you just few minutes, you just quickly calculate and tell me what will be the answer.
0.11.
Exactly. So 100 minus 80 divided by 100 plus 80. So 20 divided by 180, it will give you the 0.111. Okay. Now the next one is which vegetation index explicitly reduce the soil background influence? So basically, do you have any idea about what is soil background influence?
SKVI.
The answer is right, but do you know about what is soil background inference? Like what happens because of soil, how it affects NDVI? Any idea on that?
Just like it clears the image, like it highlights the vegetation more clearly.
Okay, so why it highlights more? Because if you take normal NDVI and let's say if we have pixel and their vegetation is very less, okay, but corresponding soil is there, or if we see the vegetation in their premature stage, when we just saw the vegetation, it just started coming out of soil, then there is a reflectance from soil which is also coming in the satellite data. And we want to remove that we have to do the adjustment which is happening because of soil. So what this index will do, it will remove the effect of soil from the pixel. And after removing the pixel, like effect of soil, it will just give the NDVI of vegetation only. So that's why, like, if you say the name also, full name of the SAVI, then it is a soil adjusted vegetation index. And there is a L factor which we are using in that. And if you want to read in detail about this indices, I will go in the site and then just check it out, its formula. So there is a soil adjusted vegetation index. There is an enhanced vegetation index. So couple of index are there which are the improvement on the NDVI index. So if we take EVI, then it's a enhanced vegetation index where we use the two different bands. So there is a correction factors which we are doing because of soil and canopy both, and atmospheric corrections and canopy background noise. So we are doing two corrections in the EVI, where the formula is we are using three different bands to do the correction. The first band will give you the idea about the atmosphere, and then other the factors which are there which will correct the canopy corrections. So this is the formula of green into, so this is the gain factor into near infrared minus red, near infrared plus red, that will be common. Then red will be multiplied some factor to multiply it with the effect of like correction of canopy noise. And then this C2 will be like blue band, and then L will be soil factor, adjusted soil factor. So which we take as a 1. So this is the formula of EVI. Similarly, you have the SAVI, which is soil adjusted vegetation index, where we use just L value rather than using the 2 or 3 corrections. So which is the formula for SAVI is near infrared minus red divided by near infrared plus red plus correction factor L and into 1 plus L. So similarly, we have multiple indices which were derived on the, like if we want to improve some or other thing, how we can use it. This similar way, this normalized burn ratio we use when we want to analyze the like how much vegetation is affected because of fire. So this normalized difference snow index is for snow, then we are having index for moisture, water. So there are multiple index which are available. So you can go through those links and you can read more about those indices afterward. The next question is principal component analysis is mainly applied in remote sensing to increase the spatial resolution, reduce the correlation among the spectral band, eliminate the atmospheric noise, and enhance the image brightness.
So reduce correlation among spectral bands.
True. So principal component analysis, if there is a multiple like correlation between two bands or more, we cannot use because they will convey the same information. That's why we want to use such a band which has less correlation among it. That's why we use the principal component analysis. In PCA, the first principal component represents
So
minimum
maximum
variance.
variance direction.
Yes, so that component will explain the maximum variance. Next question, which is not a data structure exists by the tussled cap transformation that defines the vegetation information content.
So redness.
Yes, so this is similar to PCA, but here instead of using the different bands, we use the different properties such as brightness, greenness, and wetness, and some other indices also, index. The next one is a pixel with NDVI value of minus zero point 0.2 most likely represents.
So
So
water.
yes, if you have negative value, just go away straight with water. The next question is why are PCA and TCT useful in multispectral data?
So reduce redundant information.
Exactly. So they reduce the redundant information from highly correlated bands. The next question is the band ratio in satellite image interpretation is applied to enhance the spectral separation, reduce the effect of topography, enhance the effect of topography, increase the spatial difference between bands.
Enhance spectral separation.
Okay, so this is a multiple choice question, like more than one is correct.
To enhance the effect of topography.
How it will enhance? Basically, it will reduce it because on one side of hill, if you see there is a less shade or less sunlight is coming. On one side, more light is coming. So this, when you use these things, say ratio, it will normalize those things. Okay, so it will
Yes.
reduce the effect of topography rather than enhancing it. The next one is which component in TCT corresponds to vegetation vigor? So vegetation
So
will be,
greenness.
yes, exactly. The next one is a PCP transformation applied to 7-band Landsat data yields 3 principal components, 14 principal component, infinity principal components, or 7 principal components. So if I am having image with 7 bands, and if I will do the principal component analysis, how many principal component I will get?
So infinite.
No. So basically, when you use PCA, you will get the same number of PCAs, principal components, as your number of input. So if you are putting 7 bands, you will get 7 principal components.
So but
Okay.
we can repeat also this PC transformation.
Yes, but in general, you will get this like depending on the number of inputs, whatever you got, like have based on that only you will get. So this is from your lecture slides. Uh, so here we go to, so this is the first one. That's another one. This simple ratio reduces the atmospheric and topographic effect both. And when we go for PCA, so when we have more than 2 bands, then this PCA and TCTs are useful. And then basically this is like how we are reducing the feature space. Um, Basically, it will remove the redundancy in the data. And so the first three principal component usually contains the most useful information, and other principal components sometimes useful for highlighting some features. So basically, when we are doing principal component analysis, generally we use three only, the first three, because it will produce the maximum variance. Let's see the number of PC. So basically, I went through it and shows that it will just produce as your number of input only. But after that, we just take the three first principal components. Let's see if we get that same text. So see here, all principal component x's, PCs, equal to the number of input bands which are there. Okay, so basically you will get the same number of input bands as principal components as given by your image, and the first three will be useful for the in our information extraction, and then rest of it will be useful for highlighting features. Okay, so we'll go to next. Which of the following is not a two-band vegetation index? So which of the following indexes uses more than two bands?
Sir, PCA, but
Yes.
it is not vegetation.
Yeah, but still anyway, it's a wrong answer. Okay. The Jamie index differs from NDVI by. So basically, this index is a non-linear index. I think you might not have gone through in detail, but I will just tell you that this index is uses some non-linear transformation. Because of that, it reduces the effect of soil, and it will also remove the effect of atmosphere as well, but not directly. It does not do the directly atmospheric correction. It just removes the effect of atmospheric corrections. So if you are interested, you can go through the original paper of this same index. The next one is now let's move towards the classification questions. Uh, in unsupervised classification, the bulk of analyst efforts occurs before classification, after classification, during image acquisitions, or during radiometric correction.
Sir, after classification,
Yes, and in supervised before classification to label the different data sets. The next one is which of the following is not an unsupervised algorithm? Isodata, k-means, fuzzy k-means, or maximum likelihood.
sir, maximum likelihood.
So that is a supervised classification. So maximum likelihood, then nearest neighbor, and then parallel applied. So those three are supervised. Apart from that, today we see a lot more supervised algorithm also, such as random forest, Navy Bay, then based on your decision tree, then SVM. So those are the currently the machine learning based supervised algorithms. The next one is isodata convergence threshold of 95% means, so in isodata, which is unsupervised classification, When we say the threshold is 95% convergence threshold, what does that mean? Classification stops when 95% pixels remain unchanged between the iteration.
Yes,
95%
sir.
of
First option A is correct.
yes. The next one is during ISO data, clusters are split when
Standard deviation within a cluster exceeds threshold.
yes, true. The next question is which step converts spectral cluster into meaningful land cover classes? Clustering, iteration, spectral to information assignment, or feature extraction?
Spectral to informational assignment.
So, depending on the spectral signature, we will get this. The next question is which of the following is true about k-means clustering? Number of clusters is user defined. Clusters automatically merge or splits. It guarantees the convergence in one iteration and it requires the labeled data for training.
So it requires
Uh, it requires which of the
no
following
no
statement is true? So first of all, k-means is
sir
unsupervised.
clusters number of clusters is used. नहीं,
Yes, yes, that is true because k-means will do the clustering based on the user specified numbers. So if you say 10 clusters, it will divide your data into 10 cluster, 4 cluster, then 4 cluster. That it's a user defined. The next one is compared to supervised classification. Unsupervised methods are generally
less accurate but useful when ground truth is unavailable.
yes. Next one is which is not a supervised classification technique.
Sir, like I have doubt in A and C naive Bayes and distance vector machines.
So navy
I have
Bayes is
listened about sport
yeah.
vector machines, but never about distant vector machines.
So these are like just it's like other three are supervised. So this one is a odd one out kind of question. So distance vector machines means like it's a base depending on the like distance from the point it will find and it works similar to unsupervised, which is not an unsupervised classifier.
K nearest neighbors.
Yes. Which of the following is an disadvantage of unsupervised classification?
Produces clusters that need human interpretation.
That is true. Okay, requires extensive labeling data. So that is not true. Cannot be run on multiple spectral. It can be run. Always results in poor accuracy. Not always. Sometimes it's good also. So the answer is B. Okay, so there is the option D is also some kind of okay, but the word use of word always it's making it not the answer. Next one is which parameter determines when ISO data processing should stop?
The maximum iterations of convergence threshold.
Okay, so option number A. The next one is fuzzy k-means differs from k-means by allowing partial membership of pixels in multiple cluster, produces only hard boundaries, being supervised, or needing no iteration.
Allowing partial membership of pixels in multiple clusters.
Yes, so basically it will not say that this pixel or this point belongs to this class only. Instead of it, it will give some kind of probability or weightage that it has this much probability or this much weightage to belongs to this class. So, and this much probability to go for this class. Whereas in other thing, it will just directly specify that this pixel belongs to either water or either vegetation directly. So basically, this is kind of partial fuzzy clustering. This is the hard clustering where we define the pixels either in 1, 2, or 3 or any separate class which is already defined. Whereas here it's a when the classes are overlapping with each other, we use this fuzzy classification. So it will give the partial membership. So this here it's like pink and blue color and then regions between that. So we'll give the like this values belongs to how much it has convergence to go to class 1 and how much it belongs to class 2 like this. The next one is which method is most suitable when no labeled data are available.
Sir, ISO data.
Because that is unsupervised classification where we do not need training data points. Next one is why is unsupervised classification considered computationally complex?
Iterative clustering and reassignment operations.
Okay, so all depends on how many number of clusters we want to generate and what is the convergence threshold or uh, like clustering threshold we are giving in the file. Which is or are the correct statements about classifiers? Minimum distance to mean classifier is independent of class order. Maximum likelihood classifier is most theoretically correct. Parallelized classifier is a class order independent. Minimum
Sir,
distance,
minimum distance to means classifier calculates the Euclidean distance is correct. Option D.
yes. So here in option it is written that is or are. It means it might be.
Maximum likelihood classifier is the most theoretical correct.
That is also true. And option A is also true. That minimum distance to
Yes,
mean
it is
is
independent of class order.
independent of the
Yes, sir.
class order. So A, B, and D, all three are correct. Primary purpose of an error matrix is or confusion matrix is to.
Compare classified data with reference data.
True. The next one is which type of error occurs when pixels belonging to class are
Omission error.
omission error. Producer's accuracy is associated with.
Omission error.
Just a minute. Okay. Okay. Now the next question is producer's accuracy is associated with already you
Omission
told
error.
omission error. Okay. The next question is user's accuracy is calculated as. So I think it's a.
Sir,
I will just.
to, sir,
Yes.
sir, correct pixels in class divided by total reference pixels in that class.
It's in classified class, not the reference class. Okay. that will reference pixel will become the producer's accuracy, not the user's accuracy. Okay. So like, let's say we'll go and check first of all, like how, like we'll just take one confusion matrix and we'll calculate all the statistics for this, starting from producer's accuracy. So first, let's say this is our confusion matrix where we are having three classes: soil, water, and crop. And can you say how many number of pixels are there in this, like, as per this confusion, like how many samples are there basically?
So 48.
No, see, not for soil.
The
I'm
reference
asking,
pixels
yeah, how many points we are considering here?
for soil, sir.
No, for every class. In general, when we are making this confusion matrix, how many total number of pixels we are using for accuracy assessment?
Okay, just 1 minute, sir. Sir, 100.
100, yes. So 48 plus 28 plus 24. So it will become
Yes, sir.
100. Now, the first thing is producer's accuracy or omission error. So producer's accuracy is means we are seeing from the point of view of map maker. So if I am producing map, what is the accuracy that I am generating? Like with which accuracy I can say these maps are correct. So it's a point. It's from the point of view of the person who is making a map. Okay, now how we will get to know that whether it's right or wrong? We have the ground truth point, and using that only we can say whether it's right or wrong. So here we have to consider the ground truth information. So which is over here 48, 28 and 24. So those are the information which is coming from the ground reference point and which we already know as a producer. So here what I see is that out of 48 pixels, 40 pixels are correctly classified as a soil, whereas 8 pixels are not correctly classified as a soil, out of which 7 are classified as a water and 1 is classified as a crop. But 40 pixels are classified as a soil only. Okay, so if I want to say what is my accuracy for soil class, so it will be 40 divided by 48 into
48 and 100.
okay. So for soil class,
Yes.
it will become 83%. And similarly, how much when we calculate omission errors, then we do 1 minus producer's accuracy. So we see how many classes it has omitted. So here it has omitted 8 classes. So depending on that, we can say that here 8 divided by 48. So in other sense, we can also say 1 minus producer's accuracy. Okay, so it will become around 16%. So omission error for soil class is 16. Similarly, for water class, what is a producer's accuracy? It's a 25
25 divided by
by
28
28,
into
which
100.
yeah, which is 89%. Then omission error for water is 10%. And similarly for crop class, producer's accuracy is 17 by
17 divided by
24.
24 multiply 100.
Okay. So now based on this, you can get multiple questions that arrange the classes as per their increasing or decreasing of their producer's accuracy or user's accuracy, or which class has maximum producer's accuracy, or which class has minimum producer's accuracy, or which class has highest omission error. And this kind of questions are very common in GATE examinations or your NPTEL examinations as well. Now we see the another point, which users accuracy. So that is the perspective from the user side. So whatever map you are giving to them, how much things are correct into that map. Okay, so that we will see from this column. So what is happening over here is that users are seeing 45 pixels are soil pixels. Okay, but out of that 40 samples are only soil samples. Others are, they seems as a soil but actually they are water. They seems as a crop but actually they are soil. So that as a user I am able to distinguish in that. So for that, user's accuracy will be 40 divided by 45 into 100, 25 divided by 35 into 100, and 17 by 20 into 100. And it is related to the commission error. So the class is not actually soil, but other things are making it into soil. Other, like water is there, it is making it's behaving as a soil. So that will introduce the commission error. So uh, so 1 minus user's accuracy will do, that will give us the commission error. Got my point?
Yes, sir.
Okay. Then there is a third matrix, which is overall accuracy. So overall accuracy is the sum of diagonal divided by total number of pixels. So 40 plus 25 plus 17 divided by total number, which is 100. So can you tell me the overall accuracy of this image?
So just 1 minute.
Yes, take your time.
So 77.
Yes. See, uh, diagonal 40 plus 25 into plus 17. Is it? It will become 82. So 40 plus 25 plus 17 divided by 100.
Yes, it is becoming 82. I calculated it as 77.
Okay, fine. Now there is a next statistic, which is a kappa coefficient. Okay, so this is another matrix to identify how much accurate your image classification. Here it will see that how your classification is good compared to the normal chance of agreement. So in overall accuracy, the problem is then when we do here that in this class accuracy is coming high, but within the class what is happening that we don't know. That 40 plus 25 plus 17 divided by 100 we will do, but we don't know that how much portion of accuracy is coming from soil, water, or crop. So if any, like it's will take the overall idea, not to the particular class specific accuracies. So there we have to see this agreement. What we will do, we will take the overall accuracy, which is the diagonal term, and then we'll see the chance of agreement, which will be like this diagonal pixel 48 into 45, 28 into 35, 24 into 20. So that will be give you the chance of agreement. So if you want to calculate the kappa coefficient, then the formula, if you see in book, it will be like this. So n
So
into,
is
yes,
it related to this? Is it related to this phenomena like India GDP is good because of only 1 or 2% people?
yes, similar to that. Like see, here we are like neglecting lots of things in overall
Yes, sir.
accuracy. Similarly, when we want to compare two different metrics, let's say I have done like 2% separately did the image classification. Okay. And you want to compare that image. If you use overall accuracy, then it's not a good matrix because if they have high number of data points and then comparatively their accuracy is coming good, then overall accuracy might be good. But if you see the chance of agreement, that might go less also because there we are considering both commission and omission errors together. There and overall accuracy, we are not bothering about it. Okay, so basically when we calculate this kappa coefficient, we are taking this sum, this into this. So basically it will give us the total idea, not the class specific idea. So the formula is n, which is total number of pixels. So here in our case, 100 pixels are there. Then summation of diagonal pixel. So xii, it means that diagonal pixel, 1, 1, 2, 2, 3, 3. So it will give us the similar to overall accuracy minus this row total and column total, the multiplication of it and sum of it. So basically it is uh, 48 into 45 plus 28 into 35 plus 24 into 20. So that is sigma xi into sigma plus I. And n square is 100 into 100. So if you divide it like entire, okay. So if you divide it by n, then you will get here, this is a formula of overall accuracy, and this we refer as a PE, the chance of agreement term. So if I'll divide this entire formula by n square, what will happen is it will become something like this. So this k will become, so here if we divide it by n square, so in first what will happen, this sigma I1 to k xii divided by n. So it will become like this. So this is a formula of overall accuracy. Then you are having this. So I think you got my point. So I don't have to repeat this formula. So if you divide
Yes,
it by
sir.
n square, it will become this overall accuracy term minus this PE term, where this divided by n square will become, and this will become 1 minus this same thing. Okay, so it's a like improvement in overall accuracy, and this kappa coefficient is like, if it is less than 0.4, then it's a poor. If it is 0.4 to 0.75, it's a good, and then it's let's say mostly more than 0.75, it's excellent. So I think now with this we can solve those questions which we left. So this is the user's accuracy and producer's accuracy is now clear. So user's accuracy in the classified image, and then producer's accuracy in total reference pixel or ground truth pixels. Okay, is that clear?
Yes, sir.
Okay, now the next question. In this provided confusion matrix, conifer class has 50 correctly classified out of 57 total classified as a conifer. What is the user's accuracy in this case?
So 50 divided by 57 into 100.
Okay, so it will become how much? How much it will become? 50 by 57. It will become
So
87.
just sir 87.7.
Yes, true. And what is overall accuracy in this example?
So 71.
71. And do you want to calculate kappa coefficient for practice? Let's calculate it. So first part is n square. So number of observation is 100. So 100 multiply by diagonal element, which is 71 as you calculated right now. Okay, so 100 into
Yes, sir.
71 minus, we will have multiplication of all the diagonal element like row totals, row and column totals. So first is 67 into 57 plus 23 into 27 plus 10 into 16. So we will get around 4600. Are you getting it? I will,
Yes, sir.
I will put this formula so that you can calculate.
Got it, sir. I have this formula.
So how much what answer you are getting?
Sir, actually, like I have not calculated exact values.
Okay. So basically, just go through that question, write it down. So here, kappa shan just write kappa is equal to
100
100 into 71
mul-
minus
minus
there will become
67 into 57 plus
67 into 57 plus
plus
23
23 into 27
plus 10 into 16 divided
16.
by 100 into 100 n square minus same
So 60 is, so 6 is left.
what?
So 6 is left in 67.
Oh, so 7100 minus 4600
10,000
4600.
by 4600.
So on top we will get
5
2500 and bottom we'll get
5400.
5400. So 2500.
0.5 something, sir.
So 0.46 getting 463. 25 by 40, 54.463. Okay. So here it's like
Yes,
okay
sir.
result. So overall accuracy is too high in this case, but the kappa is less, but still it's okay. Now the next question is the purpose of thresholding in supervised classification is
To identify exact pixels not belonging to predefined training classes.
yes. Now the next is this is we already done. Kappa statistics differ from overall accuracy because
It accounts for chance agreements.
now the overall accuracy of this following confusion matrix is just quickly calculate the overall accuracy. This question is from GATE exam. So sum
So
of
just
diagonals
1
will
minute.
become 105 and how will you calculate total number? So you have to do row and column sum, either row sum or column sum. So if you do here, like say in numerator, we'll have 10 plus 25 plus 35 plus 15 plus 20 divided by total number of pixels. So you multiply, like add additional, which will become around 133. And by doing that, you will end up
Sir,
in,
the overall accuracy is 81.39.
how much?
Sir, 81.39.
81.39. I'm not getting that. I'm getting around 0.789. So closely option number A.
Sir, but
Seven. I'm getting 0.79.
here it is given overall accuracy, but how? But in options it is given like they are asking for kappa, because overall accuracy will be just like 70 to 90% approx.
Okay, see,
Like
in that case, if you have not multiplied it with 100, then it will be also be considered. I mean, in exams, if it is there, then don't worry about it. If it can be expressed as a point fractions also and percentage also. So here, total number of pixels, how much you got?
sir, 129.
129. How? I am getting 133. See, like you have to do this sum only.
Yes, sir, and then they are plus.
So basically, diagonal sum, how much you have?
Sir, 105.
105. Then let's say if we include the other thing, then here 1, 1, 2, 2, 4. So this will become 109.
14.
Okay, then 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 25, 26, 27, 28, 29, 30, 31, 32, and 33. So you will get 133 as a total number of pixels.
Yes, sir, I did
Okay.
mistake in this one.
Okay.
29.
Okay, so don't do this kind of mistakes, calculative mistakes. So answer
Yes,
is 105 divided by 133, which will around point 0.8, like 79. So option A is closest one. The next one is, which sampling strategy ensures that each land cover class has minimum representation?
sir, stratified.
Yes. Systematic non-aligned sampling differs from systematic sampling by,
The random placement with systematic grid cell.
true. The statement, without an accuracy assessment, a classified map is just a pretty picture. Emphasize importance of radiometric correction, spatial resolution, necessity of,
Necessity of accuracy assessment for map usability.
yes, true. Next one is, which accuracy measures corresponds directly to inclusion error? So
So
inclusion means
users
commission error.
accuracy.
Yes. Which method quantifies the difference between actual and chance agreement?
Kappa coefficient.
Kappa value of 0.46 indicates
the 54% chance.
Chance? No. It will denote that 46% better than the chance agreement. Okay. So like interpretation, like you have to do like in this way, that there is a 46% better than, like, accuracy is 46% better than the normal chance agreement. So this is like how we do interpret the kappa. The minimum number of references samples per class suggested in literature is, so what is the rule of thumb that if we are doing
Sir,
classification?
50.
Yes. Which source is not a valid reference or data source?
Random gain values from
Which sampling design places reference observations based on centroids?
systematic.
It will be clustered, because in cluster we define a center point, and that is based on that centroid. Then one limitations of overall accuracy is
Hides uneven error distribution among classes.
comparing two classification results using the error matrix is best supported by. So if we want to
So just
compare
one
the,
minute.
huh?
So just 1 minute.
No, so here comparing two classifications. Okay, like you have to compare the classification done by two different people or two different companies. Then the, as like overall accuracy limitation is, it hides the uneven distribution of. We use kappa coefficient for this purpose to compare the two different classification.
Yes, sir.
Chalo. Any doubt in this topic, image classification?
No, sir.
Okay. So what should we do now? I mean, the questions which I prepared, that's already over now. So I have few more questions which I prepared for last year. Uh, can we solve that, or do you want to see something else?
So whatever
Any?
you prefer.
Yeah. So let's see if my Google Earth Engine code. So from where you are learning Google Earth Engine? Okay.
So currently I'm not learning. Actually, when I was doing internship in IIT BSU in summer internship, so there I learned using this Google Earth Engine.
Okay, so if you want to start learning it, there is a good book which is cloud-based Earth Engine.
So actually, I thought to learn from your the that courses which you recommended me.
Yes, yes,
Sir, but due to a lot of work in ongoing third semester, I'm not able to find
sure.
like to.
Uh, Hi, Sachin.
Hi, sir.
Yeah, so we have just finished the question answer session. Uh, if you want to go through it, you can go through the video recordings of it. Now we are starting with some hands-on on Google Earth Engine. Basically, if someone wants to learn, then how they can start. Do you have any previous background in remote sensing data analysis?
Uh, Actually, no, sir.
Okay, so you are from which background?
I'm civil engineering from
Okay,
background.
and you are BTech, MTech, PhD student, which?
B, B, sir.
Okay, which year?
2012.
Okay, fine. Let's. So basically, yeah, if there are like satellite captures a lot of data, okay, and now how to use this data. So for that, earlier we used to use different softwares, such as in which you have like ADAS is there or NV is there for remote sensing data analysis. But last 10 years, or let's say 5 to 7 years, this we are highly using this Google Earth Engine, which is a cloud-based platform to do the image processing or anything with images. So the good thing about Google Earth Engine is that you do not have to download the data set. If you are working with ADAS or any other image processing software, then first of all you have to download the data set. And basically, if you download one data of any one file, then that will be around 1 GB. So the main problem is that you need a lot of space to do the analysis. And because of that, it becomes very difficult to handle the lots of data. So here in Google Earth Engine, they have stored each and every imagery in Google server only. And then we are whatever the analysis which we are doing on that imagery only on cloud rather than downloading and doing the data. Once we are done with our analysis, then after we can export those imagery into our Google Drive and then we can use it further. So basically it has multiple satellite imagery. We will write some algorithm which will be in JavaScript, and then we can solve a real life problem using that. So there are multiple videos or tutorials available in like YouTube there from where you can learn this Google Earth Engine. And once you done this thing, then you can develop a like different dash portals. So basically, here I will show you some applications. So you can generate this kind of applications using Google Earth Engine. So here it is for different kinds of species. You can explore the different species in different regions and how their patterns are changing. So you can make this kind of portals, which is the geo portals or geo dashboards. So basically, when you click on any particular species, and it will redirect you to the locations where you can found out that particular species, so where it is like available or where you can find that species. So this is just one kind of application. Apart from that, there is a another thing. This is global forest cover change portal. So if you go through this portal, then so this is another dashboard which gives the pixel-wise forest cover loss where the forest covers are changing. In addition to that, so this portal is from this particular paper, High Resolution Global Maps of 21st Century. Now, let's say if you want to learn Google Earth Engine, then how you can start learning it. So basically, you can go through their main site of Google Earth Engine. There you can see some videos on that, and then if you go down, then you see here the ready to use data set. So whatever the data sets which are present here, that you can see. So this is the data related to surface temperature, data related to climate, atmospheric data, weather data, and then these are the various imageries which are present for free of cost. Then there are some high resolution satellites or satellite imageries are also available. Then these are the terrain products such as DEM, DTM, and then other geophysical data such as night light data, and other data sets which may be referred biomass or derived from the satellite data. So this refers the some kinds of roads, highways, and DMs, sometimes tidal data, forecast data of future. So these are the different geophysical variables, rainfall, temperature, similar to that. Now, let's say if I want to see the imagery, let's say start with the Sentinel. So I will click on Sentinel, and then it will show you the different Sentinel summary. Like Sentinel-1 is SAR data, which we use for mostly for flood application and earthquake application and such applications. Then this is the multispectral data, which is like kind of normal image which we see, but in multiple bands. Then this is Sentinel-3, which is for ocean and land color instrument (OLI) sensors. Then this is Sentinel-5P, which is useful for the monitoring of troposphere and the various gases present in the troposphere. And these are the like what we learned today's class. So once after doing the image classification, they have prepared the various LULC map at 10-meter resolution. So you can go through that products as well. So right now, first we'll let's say try to see this multispectral instrument. So MSI data. So click on that. Now, so after that, you will see that there is surface reflectance product and there is a top of the atmospheric reflectance product. Surface reflectance, like we are removing the effect of atmosphere, and that's why you can see if you compare this both imagery, this top of the atmosphere reflectance, can see some white patches, but in this surface reflectance, you cannot see that white or foggy image because we have already removed the effect of atmosphere. Now, if you go to this, click on that, it gives the data at every 5 days. This is how you can recall the data. This is the different kinds of bands which are available, and then this description, whether it's a blue band, green band, red band. Then there is a image property that which kind of like what is the cloud cover, what is the area, so which kind of property it is having, what is the gain and offset for that particular band, solar radiation, solar radiance. So all those things are given, and then description about the imagery, who collected, when collected, through from which portal they are getting the data. And at the bottom, you will get the sample code, which is written in JavaScript and Python. So if you don't know anything, just go use this sample code, click on open code editor. So if you have account in Google Earth Engine, it will open this script into your Google Earth Engine window. And then after you just click on run. If you will run it, then you will see this kind of image, which will represent the actual data. So this is the image of Vishakhapatnam on 1st January 2020, like in the 1st January month. Now let's say I want to see the current image. So I will write 2025 and month is 9. So empty dates. So there is okay, the date we are not kept properly. Okay, so basically if image is available, it will show. If it is not available, it will not show. So if for the month of current month, image is available at these locations only. So we'll just write the previous month. So it has some latency also, that every time image will not come exactly on the same date. It will take some time, and then after it will upload it. So we can see the now, like in the month of August, if we see, it will take some time to load because we are handling multiple datas. And then another thing is I have kept the cloud cover threshold of less than 20%. And this is being a monsoon season. There are multiple clouds over the different land areas. And because of that, we are not getting an image because we have given the hard threshold on cloud cover. But with this cloud cover also, you can see some images over the desert of Thar. And we can zoom it and check it out. Like this is the Indira Gandhi Canal. Okay. So like this, you can explore the various data sets. And if we take some, let's say, post-monsoon season of 2024, then it will be very much. So basically November, October, November, December, if you will write, then you will get very clear image of different areas. So you can see now we'll getting in this. So we'll see over Gandhinagar or Gujarat. So you can see very a clear image right now. Okay, so like this, you can explore the different images and let's say how good we can see. So you can see now in this image, this is the IIT Gandhinagar where I am from. So you can see the structure, infrastructure, hostel area, housing area, then the grounds, you can see the different grounds, football ground and cricket ground. You can identify the even shape of the ground also, and then you can see how much water is present in the river. So those things we can see from these images. Okay, so this is the first thing, like how to explore the different images. Now, this is just Sentinel data. If you are interested in exploring more, then you can explore the Landsat data as well. So for that, you just have to go back instead of Sentinel, select the Landsat series. So click on Landsat, and then you can have multiple product of Landsat 9, Landsat 8, Landsat 7, 5, 4. So if we see Landsat 9, then also there is surface reflectance product top of the atmosphere, and this is the raw image. So here we are getting three different products. Similarly, we'll go to surface reflectance, and if I will open this code in code editor, and then if I will run it, I will get in Landsat view. So you will get the data like this. Okay, now how we can visualize. If I same image I want to see as a uh, instead of two color composite, if I want to see it as a false color composite, so I have to change the band. So in Sentinel 84N 3 band represents false color composite. So if I will write 843, then I can see my image as a false color composite, and you can see now properly that using this false color composite I can see the clear separation between the vegetation and water, as it is very clear. But as I had earlier the same image, so we'll show both image, one with true color composite and one with false color composite. And let's say write FCC. I will show it in a big screen so you can. So now see the why do we do the false color composite? So you can see now in this image I can't see much, because like here you can see the color of vegetation and water is being same only, like so that it's very difficult to differentiate between vegetation and water. But if I go from here to this one in false color composite, I can clearly define the boundaries of water and designate the canal or river. You can see this is like very confined water channel. It means it reflects canal because it's a geometry shape. You can see it's going in proper. So this is the Narmada canal. Whereas you can see this one is a Sabarmati river. And you can see here like water is not here after this thing. So what might it indicate? So what?
Barrage
Please
or dam.
repeat the question.
Yeah, so here you can see water is there till this point, but after that there is no water. So what might this structure will be?
Barrage or dam.
Yes, so it is a barrage or dam which is holding the water. So that you can identify. Okay, so you can see here, if you zoom it, you can see that there is a like small dam is there, which is known as a Sunsarovar Dam, which is holding the water, and because of that, you are not seeing anything. Okay, so like this, you can experience different visualization. You can separate between different classes also. Another thing is you can see here, this patches looks very brownish, whereas these patches are looking like a green, like very reddish in nature. So if you want to differentiate between these things also, then it means that here it is agriculture land, but mainly it's dominated by soil. You can see, and there is nothing on that particular land. They have not taken any crop yet, and because of that, you see the land as a soil. But similarly, if you see river, okay, then river soil, it will be like it's not a soil, it's a sand. So if you see river and there is no water, it means it's a barren land only, but you see very bright pixels. It is because of the sand. But if you have soil, then its brightness will be less compared to sand. In sand, you will see more brightness, whereas in soil, you will see less brightness. Similarly, here you see the proper green color. Green patches are there. So it is a highly dense vegetation. In dense vegetation, we will see where we have forest area. So this entire one is a forest area. And similarly, here you can see the shapes. So shapes will define the boundaries of your agriculture farms. And because of that, you can see these are the agriculture farms. So here the vegetation represents crop, where here the vegetation refers the forest count. So like this, you have to do satellite image interpretation when like just importing the image. The first task is to get the area, and then after you have to do the image interpretation, where you will get to know about the different different objects. And then when you have this high-rise buildings, then sometimes you will see the shadow also. See here, you can see the shadow. So it means the image which we have taken, it's not exactly at the nadir. It is at some inclination, and because of that, we are able to see the shadows. Another thing is this buildings are very high-rise building, and because of that, it is producing the big shadow. Similarly, if we see here, these are the gift city. So they're very, yes, high-rise buildings are there. So you can see a shadow size is very high. So depending on which time we have captured the data, this also matters. So all those things you have to understand after getting an image. And then after you have to start doing some analysis on it. So I think let's go into detail afterward. Okay, so this is about the data sets which are there in Google Earth Engine. After that, you can explore similarly any data sets. And now convenient tools. So this is the code editor in which we have just wrote the code. So you have to make your account in this code editor through which you can do all the calculations and do the all analysis. After that, like this is the impact. And if you want to make an account, you have to register yourself over here. Now, what we can do is, let's say we will see case studies are two only. So there is another portal which is Global Forest Watch, then tiger habitat modeling. So these are the malaria risk mapping. So these are the kind of applications which you can do using Google Earth Engine. So this is the data collect Earth. So it's collecting different data sets. And real few days back, this Google also has launched this AI portal database repository where they have multiple data sets in one way, and through which you can earth cubes, you can identify different things. This is another product which is a global surface water. So here you can see like what is the availability of water, whether the water is available for all 12 months or at given locations, or whether the water is like river is perennial, like so during monsoon there is a water, but after that there is no water. So these things also you can see, like it's taking time to load, but so these are the various applications you can do. So now we have covered like what is Google Earth Engine, and what kind of things you can done it and what kind of data it has. Now let's say you want to start learning it. So I recommend it, like if you want to learn it properly, and if you are okay with learning from websites, then you can start using this book, Cloud-Based Remote Sensing with Google Earth Engine. So in this book, there is a two kind of chapters are there. First one is the fundamentals and the second one is application. The fundamental will teach you about the different imageries, what kind of operations you can carry out, like playing with raster data and vector data. And the application is the different application for water resource, biodiversity, forest cover, crime. So there are multiple applications. There are 24 chapters are there. So if you click on go to book, and there are video summaries are also available. So the first part is a fundamental. In the first chapter, you will learn about the basic programming which is required for Google Earth Engine. It is using JavaScript, so you will learn about JavaScripts and about the different data sets, how to explore image, which we have done today. Then what are the different vocabularies, so terms which we use with remote sensing imagery. Then the second module is about interpreting image, what we did right now, that if we have multiple image, how to identify different objects, how to take mean or median, or how to, like if we are having 10 images in a year, so how to make a composite of that image, how to take mean of it, median of it, so how to apply different threshold mask. So this, then image classification, which we learned accuracy assessment, so those things will come into the interpreting image. Then there is the advanced image processing, in which the machine learning based approach will be there, depending on the segmentation, pixel to pixel, neighborhood based, and object based image analysis. Then there is a fourth section in
Excuse me,
which,
sir.
yes,
Sorry to disturb you.
yes,
Sir, because of an urgent work, I had to leave the class. May I?
sure, 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 you can leave.
Thank you so much, sir.
Yeah. So after I'm just explaining this thing, because if you are interested, you can look into this and you can learn about the Google Earth Engine. Then we have this interpreting image series, time series. So basically, if you have this raster data, how to generate a time series from it. So that part is uh, covered here. Then how to use with the vector data when given that within this 20 kilometer of this river or 10 kilometer of river, this find out the statistics. So those things you can do here with the vector data. And then there are a couple of advanced topic of sharing, making a UI, UX or app from Google Earth Engine. So those things are here, so you can like work with the satellite data and learn this thing. Once you are acquainted with the skills, then you can start the application module, where application for human application, aquatic application, hydrological, terrestrial application. So forest fire is there, then the various things are there. So basically in human applications, agriculture, urban, built up area, air pollution, heat island, health applications are there. Then here in aquatic, groundwater monitoring, surface water monitoring, river morphology, water balance, seasonality is there. And here in terrestrial application, forest fire, mangroves, forest detection, deforestation, and those applications are there. Conservation efforts are there. So the approach is that very good. This book is used. Video summaries are also available. You can go through any applications. Let's say if I go to aquatic and habitat application, I will click on that and I can go to any given module, and then codes are there, explanation of those codes are there, what kind of tentative results you will get, that is there. So you can learn this properly using this book also. And if you are interested in, some videos are also available on the same book from the authors who have written this book. So this book is authored by multiple authors, so they might have their own video channels through which you can explore. And there is one such by Ujjwal Gandhi. So you can go through it and you can like see the applications or videos there as well. So that's said about the Google Earth Engine. So if you want to learn, you can go through it and start learning it. Apart from that, if you have any questions that you can ask. So do you have any questions about the content of this course, or Any doubts in this course till now? You have faced any issues or something? So, do you have any questions, Sachin?
Sir, I have a basic question.
Yes.
Why, sir, what kind of career choices or job are available in this field?
Okay. So basically, after pursuing like two or three subjects, basically this remote sensing, GIS, geomatics engineering, you can apply for various like jobs in ISRO space application centers where they use these data sets and like create products for different part, like whether it's flood related, natural hazard related stuff, or monitoring different assets, or mapping the agriculture, or any other policy level guidelines. So one thing is you can apply in this ISRO based jobs. Second thing, you can go for the various multinational companies, such as VRISC is there, then World Bank is there, then there is one more company is there, Equa Connect is there. So all of them use this satellite images and then uh, do this remote sensing based analysis. In this course, if you go for field based work, which is includes survey, then you can go with DGPS survey, drone survey, LIDAR survey, so which are very in demand right now, because every government projects or any commercial projects, if they are coming, they have to do a survey. So how you can provide them accurate survey of land so that they can create an infrastructure over that. So that is another part, and mostly in that, people are doing a lot of startup right now. That whether it's a drone survey or whether it's a lidar survey or whether it's a subsurface survey, like what is below this ground. So based on that, there are multiple companies are there, uh, so you can explore those startups. And apart from that, there is a like if you are interested in learning more on these topics, you can always go for the higher education. And there are particular colleges which offers the course on this, so you can go for that as well. Yeah,
Okay, sir.
depending on once you explore this thing, you will get to know. But there are multiple companies who are working in this area in India as well as in
Sir,
outside also.
sir, what kind of skill set required for MNC or this job?
So basically, you should know one or two software. Basically, in market, people use ArcGIS and QGIS. ArcGIS is a commercial one, and QGIS is an open source. Anyone can learn it, code, modify the codes and all. So any like need of any GIS software where you can analyze all this data, some background on programming, so that once you are okay with the data, how you can automate this process so that you can do it for larger areas. You have set up your model or programs on smaller area, but now you want to extend it for India or for particular city or for particular state. Because if all the agencies will not work with limited area, they will work with the bigger areas. So how to automate this codes using Python or JavaScript, so that thing. After that, you should know how to make a dashboard using these data sets. So for that, if you are knowing some context of JavaScript or HTML front end, back end, that will be good. But that is like you want to do overall skill set development, then it's necessary. Otherwise, you should know this GIS software first. Second thing is you can go with start with the Google Earth Engine for remote sensing data analysis if you want to go towards this software side. And if you also want to go towards the hardcore side or field type of work, then you should know the survey, basically DGPS survey or drone survey. You should have drone license also. So those things, and total stations, robotic total station, LiDAR scanner. So you should know how to operate those scanners if you want to go for field jobs. And desk jobs, you should know the two or three softwares, basically this GIS software and remote sensing softwares or Google Earth Engine as initial skill set.
Okay, sir. Thank you.
Okay, so if there is no more question, we can close this session. Thank you for joining. And have you registered for this course?
Yes, sir. I have registered for.
Okay, so if you are giving exams, you can go through the recordings of the doubt session. From that, you will get to know the different MCQ questions. And in a like a discussion session, also we have given the links, so you can explore all the PDF and PPTs of this doubt sessions from there as well.
Yes.
Okay, thank you for joining. Have a nice day. Bye bye.
Bye.